All right, so finishing up our last example here, we have the basketball player shoots at the basket. Ball leaves the player's hand with a speed of 7.2 from a height of 2.21. So here's the hoop. And so the basketball player, let's assume they jumped. Okay, they have just really long arms. So that's what it looks like. So that ball is leaving from 2.21 meters in height. What's the speed of the ball as it goes through the hoop at 3.05? So the hoop up in the 9-foot range. How fast or what is the velocity as it goes through there? It's really a two-part question, but in this, it's your upper level, I guess, word problem for this particular topic. They removed the A and B part. The only way you can find your velocity at that peak is by knowing how much energy is in the system. The only way you know all the energy or all the factors involved is at that point there. So we need to calculate our total energy in the system at that point. And it is going to be a combination of kinetic and gravitational potential. So 1/2. Doesn't tell us the mass of the basketball, which actually makes the question a little bit easier for me. Just don't have to go grab the calculator. And a speed of 7.2 squared, so that's pretty good shot speed, plus mgh 10 and the 2.21. So what that allows us to do with that m in there, and just one last calculation, we're just carrying the m through, 0.5 times the 7.2 squared plus 22.1. So we end up with 48.02 m joules of energy. So therefore, total E is the 48.02 joules. Oops, I forgot my m. 48.02 mass times mass, joules of energy. So we want to know the velocity at the peak. So at hoop, we got to make an assumption here. We assume, well, we don't really have to assume anything because we know the height. We know h, or delta h, is 3.05 meters. Same formula, ET equals EK plus EG. Total energy in the system, 48.02 m equals EK is 1/2 mv squared, and we're looking for V, plus gravity's m times 10 times the new height, 3.05. Everything has an m in it, so we could divide every term by m, and the masses cancel out, which they will do a lot of times in these questions. So finishing it off then, I will have 48.02 equals 1/2 v squared plus 30.5. So as I go through and do my calculations, minus the 30.5 from both sides, we get 17.52 equals 1/2 v squared. Divide both sides by 0.5. And we take the square root of both sides. And we find that it's passing through at 5.9 meters per second. So the basketball has lost velocity. It started 7.2, now it's at 5.9. And it is that transfer. We know all the information at one point in time. And if you know all that information at one point in time, you know the total energy in the system at any given time in this question. So that means that at that point forward, you can find a particular variable, whether it's going to be your V or your delta H, depends on the situation. So if you know total energy at one point in the closed system, you know it for all parts in the system. So that being said, here's the assigned homework. Excuse me. It is a review of the grade 11 material. So you should be able to move through it at a pretty brisk pace, but it also is a good review, especially for the people that haven't seen this in a year or so. So anyway, good luck. If you have any questions, you know I'm going to be floating around in class to assist you as needed. I will be at your complete disposal next day. All right. Have a good night. We'll see you tomorrow.